Okay, I know a few of you guys might have been in the RTI time when we went over this, so I wanted to make this video to make sure everyone was on the same page. So, rational inequalities are pretty simple, just depends how the inequality is set up. So inequalities are any of those ones that have, there we go. So any of the ones that have like a less than or equal to or greater than sign. And then your goal is to get a 0 on the right side. So something is less than 0, something's greater than 0. So like number 1, we already have a 0 on the right side. Okay, problem number 2, we don't. So that's when we have to take this and move it to the other side. So just like we have like x plus 1 equals 5, when we move it, we subtract. We do the opposite. So here, the opposite would be to add it. So it's just going to go right in the front over here. So we get 11 over x minus 6, take away 10 over x minus 5. And then the right side's now a 0. Okay, when we do inequalities, we want to look at each piece. So I put a parentheses around the whole numerator, around the whole denominator, and you want to break it down if we need to. Problem number 1, if you take a look, problem number 1 does not have any pieces that need to break down. There's no x squareds. So we need to find the critical points. Okay, so for the numerator, the critical point is wherever we get this equaling 0. So if you undo it, plus 7, x is 7. With the denominator, if you set this equal to 0 and solve it, we get x equals 1. Okay, and the reason we separate numerator and denominator is because the brackets only go on numerator pieces if we have a bracket in our final answer. Okay, these 2 points are going to go on a number line. We have negative infinity, positive infinity, 7, and 1. Make sure those go in the right order. So now what we're going to do is just test an area. So I'm going to test 0, let's say, and that's in the area from negative infinity to 1. So when I test it, I plug it back in the original problem. And here, when we solve it, we get positive 7. Okay, the next one, if we test an area, so let's say I test 2, because that's between 1 and 7. We test it, and we get negative 5. And I really just care about the sign. And then the last area, let's say we test an 8. 8 minus 7, 8 minus 1, and we end up getting 1 over 7, another positive area. Now we have the signs for each area. We need to know if we want the positive areas or the negative. So we look back at our inequality. Negatives are less than 0. So I want this section. So it starts at 1 and ends at 7. And with these kinds of inequalities, they're always parentheses no matter what. So 1 to 7. If we had the 2 positive areas instead, that's when you do the union between them. And then the last thing with this, so if it had been a bracket instead, that line underneath, then only the numerators get brackets. Everything else gets parentheses. Okay, looking at problem number 2. This one, again, pretty straightforward. We just need to make the denominators be the same. So this one is still missing an x minus 6. This one is still missing an x minus 5. So we get 11x minus 55 over those 2 parentheses minus 10x minus 60 over those 2 parentheses. And the nice thing is that if you have the same denominator, remember with adding and subtracting, they combine. So we end up getting 11x minus 55 minus 10x minus 60 over that same denominator. It doesn't change. And we do have to keep the inequality and we want to simplify the tops. We end up getting x, x plus 5 over this. And I'm going to put parentheses around that. So our critical points in the numerator is just x equals negative 5. Remember, we undo it. Denominator, we have 2. X equals 5 and x equals 6. So we're going to have a lot of numbers on the number line. So we have negative 5, that's the smallest, then 5, then 6. And we're going to test these. So I'm going to test 0, which is right here. And I'm just going to use this last equation. So 0 minus 5 over 0 minus, oops, that's a plus 5. And 0 minus 6. So we get 5 over, let's see, yeah, 5 over 30. And it's positive. And there's a little bit of a shortcut. So as long as this equation you're using doesn't have any exponents, each of these areas alternates signs. So you kind of save yourself some time there. You don't have to test every area. But you will get docked a bunch if you get those signs wrong. So if you're not sure that you got the first sign right, then go ahead and test them all. Or if you don't want to use the shortcut, that's okay, because you want to make sure the signs are correct. Oops, and I got that sign wrong. That should be a negative area. Okay, greater than 0. Positives are greater than 0, so we want this section and this section. So here and here. Okay, now only the numerator, take a look, we've got the bracket there. Only the numerator number gets a bracket, so negative 5. So bracket, parentheses, parentheses, parentheses. You're just putting it around those positive areas. So this one started at negative 5 and ended at 5. Then we jump an area and go from 6 to infinity. So our final answer, even though you had a ton of work, our final answer looks nice and pretty. Just that short little phrase. Okay. I'm going to show you the third example, even though we didn't do that in class. So the third example, oops, where'd it go? There it is. Third example, you just put parentheses around these. Critical points, numerator is x equals negative 5, because you're undoing it. Denominator is x equals 4. Number line, 4, negative 5. I like to test 0, which is right here. So 0 plus 5 and 0 minus 4, we get negative 5 over 4. So those must be positive. And you can test another one if you feel like it. And less than means the negative area. And because we have that line underneath, we're going to put a bracket at negative 5. So right here we'll have a bracket, and this has to have a parentheses. So negative 5, 4. And that's it.